Continuing our discussion, Lesson 3.7, Simplifying Algebraic Expressions. If we look at workbook page 39, number 1, they want us to combine like terms to simplify each expression. So looking for like terms here, notice the first term has a z squared. So what we're going to do is look for any other terms that have z squared on it. And you'll notice the last term here also has a z squared. An important thing when you're looking for these like terms, you need to make sure that you circle the sign to the left of the coefficient as well. Circle the sign to the left of that number. In this case, at the end it's minus 1/2 z squared. Okay, that's important. If you want to, you can rewrite these and put them right next to each other, if that makes it easier for you to look at. And then we can combine those together. So 1/2 z squared minus 1/2 z squared. Well, we know 1/2 minus 1/2 is 1. So that would be 1 z squared. If you look at the next term here, the next term we have 3/2. So if we look for another term that's just a constant, just a plain number, we see minus 3. Okay, the book's got this in a little different order than what we're doing, and that's okay. So 3/2 minus 3 we know would be equal to 1/2. And then finally we have some z terms. So z terms, we have a 5z and a 6z. Okay, if you want to, notice I'm doing different shapes here. Okay, so if you don't have a colored pencil or something, you're just using your pencil, you can use different shapes. If you have different colors, you want to use colored pencils when you're doing this, that's fine too. Just to make sure you can see what the like terms actually are here. Okay, so that's adding. We got 5z plus 6z, so that would be 11z. At that point, you want to verify with your final answer that you don't still have any like terms. So we've got z squared, we've got a z term, and we've got a constant. Okay, even if the letters are the same, if one has an exponent and one doesn't, those are not like terms. They have to be identical to each other. Okay, so z squared and z, those are not like terms. Cannot be combined. Another problem I wanted to mention, they don't have this in the book here, but if you get a problem like this, 2x minus 2x. So sometimes people see this problem and they say the answer is x. Well, we'll restate this only without our variables there. 2 minus 2 is what? Well, 2 minus 2 is 0. Okay, well, we're doing the same thing with our variables here. We're subtracting our coefficients. So 2x minus 2x, 2 minus 2 is 0. This would have to be 0x. And we know if you take 0 times anything, you just get 0. So one way to think about this problem, 2x minus 2x, is basically whatever we had, we're taking away the whole thing. Whatever we had, we take away the whole thing, we're left with nothing. So final answer would be 0 on a problem like that. We go down to number 11, and again, trying to look for like terms here. So first term's got an x in it, and then I've got another term over here with an x. So 5x plus 2x. If you want to rewrite them next to each other, you can. Okay. If you're able to go right to it and say, well, it's going to be 7x, that's fine. Just be careful if you're doing that without rewriting them next to each other. we've got a 1/2 and a 1/4. Those are both constants that can be added together. We know before we can add fractions together we have to get a common denominator. So 4 is my highest denominator. That'll work. With the 1/2, we can get a common denominator there. So that's 1/2 is the same as 2/4. 2/4 plus 1/4 is 3/4. And then we've got a plus 3y and a minus 2y. So 3y minus 2y, 3 minus 2 is 1, so 3y minus 2y would be 1y. So this would be our final answer. If you ever are doing a problem like these, remember too, if you have them in a different order, as long as you have the correct sign next to your term, you're allowed to do that also. So for example, 7x plus 1y plus 3/4 would be the same. Also, you don't have to put the 1 in front of the y. Most people like to put it there. But technically, you multiply something by 1 doesn't change it. So 7x plus y plus 3/4, for example, would also be an equivalent answer. Number 14, Shay sells bracelets at the farmer's market. For each bracelet she sells, she spends $1.50 on beads and $3 on hardware. And she also pays $10 per day to rent a booth. So part A, they want us to write an expression that represents Shay's total expenses if she sells X bracelets per day in 4 days. So what we want to think about for this problem, different ways of doing it. One way, we could just individually look at our different parts. So like one of her costs would be for the beads. So we could just look at her cost for the beads. So it's $1.50 per bracelet. If she sells X bracelets per day, that's $1.50 times X. Now that's for 1 day, because this is how many she sold per day. So if we do that for 4 days, she would have 4 times that amount. The hardware would be another part of her costs. So the hardware, it's $3 per bracelet. So that could be 3x. That's for 1 day again. So 4 times 3x. And then we have the booth cost as well. Booth costs a little simpler for us maybe to look at, but it's $10 per day, 4 days. So that'd be 4 times 10. So this would be one option for an expression. We can talk about other ways here in a minute. And then the next part, on part B, it says they want us to write a simplified equivalent expression. So we're going to simplify this. The first part, we've got 4 times $1.50x. If you work out 4 times $1.50, that's $6, which is the same as 6x. 4 times 3x, 4 times 3 is 12, so that would be 12x. And then 4 times 10 is 40. Be careful doing this, but what I'm doing basically is that I know all the multiplication is going to come before the addition. So that's how I did all 3 of those at the same time. Safer way, 4 times $1.50x, bring everything down, and then go from there. At this point, we can actually combine the 6x plus 12x together, which would be 18x. And so 18x plus 10 would be our simplified equivalent expression. Like I said, there are some other ways we could have answered this for part A. So we could have done, just to show you another couple of options, you could have said $1.50x plus 3x plus 10. That would be like our daily costs altogether. And then we could take that whole thing times 4. And in that case, we would be using distributive property if we wanted to simplify for the next part. Or maybe you took all your bracelet costs together. You said, well, $1.50 for the beads, $3 for the hardware. That's $4.50 for each bracelet. So you could have said $4.50 per bracelet, X bracelets a day, $10 a day for the booth. Okay, so that would be our cost for one day. And then take that thing times 4. Okay, and you'll actually get the same answer there as well. Okay, or 4 times your total bracelet cost, so 4 times 450x that we're paying each day for the bracelets, and then plus 4 times 10. Okay, so that's 4 different ways that we could write an expression that technically answers what they're wanting us to do in part A. Alright, so there might be more than one way to do this problem and still get the correct answer. Number 16, at a drive-through restaurant, Casey's family ordered a small drink and M medium drinks. Annika's family ordered M medium drinks and a large drink. Write an algebraic expression that shows the total cost in dollars of both orders. Okay, so we got the two different families. We're going to combine the costs together. So for the Casey's family, a small drink and M medium drinks. So we can see the small drink would be $1.10. So for Casey's family, I'll put in using black here. So $1.10 would just be our cost for the small drink. And then M medium drinks. Medium drinks are $1.25 each. So the M medium drinks, we would need to do $1.25 times M. $1.25 times however many we bought. And then if we look at the other family, they ordered M medium drinks and a large drink. So medium drinks, once again, would be $1.25 times M. They happen to buy the same amount as each other. And then the large drink would be $1.50, so plus $1.50. Remember, when you're writing an algebraic expression, it should be all on one line. So this could be an algebraic expression for our total costs. Understand, generally, what we're trying to do in this lesson is not only write expressions, but also have them simplified. So let's try to simplify this. So look for some like terms. So we have some M terms that are like terms here. Plus 125M, plus 125M. Don't lose your signs with these. And then if you add those together, make sure your decimals are lined up, you would get 250 times M. Also, we have $1.10 and $1.50 we could combine, would be $2.60. If you did this the other way around, since we're adding, it doesn't matter. So in other words, if you had $2.60 plus 250 times M, that would be okay also. Either option here, okay? Either option would be fine. The zeros technically in the hundredths place, we don't need to have those there. since we're talking about money, a lot of times we'll keep numbers in hundredths place, but again, it doesn't have to be written there either. 23, they want us to write each expression below in the correct column in the table at the right to show whether the expression is equivalent to 1/2 x plus 4.5 plus 1/2 x minus 1/2. So probably a good first step here would be trying to simplify what they've given us. It's kind of difficult for us to tell if it's equivalent when we've got all these different terms that can be potentially combined together. So like terms that we have here, we have 1/2 x plus 1/2 x, which would be 1x. We also have some constants here. 4.5 minus 1/2, which would be 4. So we would end up 1x plus 4. Understand 1x plus 4 is the same as x plus 4. We don't necessarily have to put the 1 in front of it, but multiplying by 1 doesn't change it. So there's actually only one expression that's going to be equivalent here, which would be the x plus 4. So equivalent, we would put x plus 4, and then not equivalent would be the other 3. So 1/2 x plus 4, x plus 4.5, and x minus 4 are all not equivalent. So this gives you an idea of how to simplify algebraic expressions.